Today we're looking at lesson 8.5 on using the distributive property, and this is having to do with factoring polynomials. We'll get back to this, but one of the strategies is a polynomial can be factored by grouping, so we'll come back to that one. But first we're going to factor this. So with factoring, you're looking for common factors. And if it's letters, common letters. And what you're going to do is you're going to, kind of like the reverse distributive property, you're going to take them out of the parentheses and put parentheses around what's left after you've factored. So if you look at 15 and 3, 15 and 3 have a common factor of 3, so I'm going to factor that out of each term. So, and they don't share the same variable, so they're going to have to stay there. But if we take a 3 and divide it from 15, that gives us a 5 left over, and the W did not change. And then if we take the 3 from a 3 and divide, that gives us 1, which we don't have to write, and we don't have anything to factor with the V, so the V stays there. So this would be the most factored we can get. The next one, again, we're looking for common factors, whether it be numbers or variables. So this one, we have a common factor of 7, but that's only for 2 out of the 3 terms, so we can't take a 7 out. We do have all 3 terms with at least one U, so we're going to take one U out. And we have at least all 3 terms with at least one T, so we're going to take one T out. So if we take one T out and one U out of the first one, that means there's only one U and T left over, because there was 2 to begin with. And we didn't do anything with the 7, so we rewrite it. And we only write it with one U and one T. And then we do the same thing. Take a U out. Didn't do anything with the number. So if the U is out, there's no more U left. And one T, so there's only one T left. And then again, if we take a U and a T out, then that's going to just leave us with the number 1. So this would be the most we can factor. Here we are going to factor by grouping. So I said we'd come back to that. If you're grouping, you have to start with at least 4 terms. So if it has 4 terms, you're going to try to factor by grouping. The other parts that we need to make sure are part of this before we start is that terms have common factors that can be grouped. So you have at least 2 terms that have common factors that can be grouped together. And then you have to have at least 2 common factors that are identical or opposites. So this has at least 4 terms. There's at least 2 terms that can be grouped together. So we're going to group, and this is usually what you do to begin with all factoring by grouping. We're going to group the first 2 terms together, and we're going to group the second 2 terms together. Oops. Parentheses. So from each term, we're going to take what they have in common out, factor it out. So for the first 2 terms, they both have an N in common, so we're going to factor out an N. What's left over is an R plus 5. And then the next 2 terms have a -1 in common, so we're going to factor out a -1, and we're left with R plus 5. Because your goal is to get both sets of parentheses with the same 2 terms. So you're going to take for your final answer and write what's outside of the terms, or outside the parentheses, as one group, and then what's inside the parentheses, since it's the same, you write it once, as your other group. So this would be my final answer. Here's another where we can factor by grouping. So we take the first two terms and the second two terms and group them. They have in common a 3 for the first two terms and a p. So that means the n is left over for the first term. If we divide 15 by 3, that's 5. And we took the p out, so we're going to just leave it as n plus 5. And then the next grouping, they have a negative 4 in common, so we're going to take that out. Whoops. And then what's left over is, again, an n plus 5. And then you have your two groups, 3p minus 4, and then n plus 5, and that is your final answer. Here's one more. You're going to take the first two groups and the second two groups, or second two terms. The first ones have a c in common, so we have 1 left over minus 2d, and the next one has a 4 in common, so we're going to take out the 4, and we have 2d minus 1. Since the first grouping is opposites of the second grouping, we're going to take out a negative 1 on the first grouping and make the c negative. So then this would become a negative 1 plus a 2t. And that's going to be the same thing now as the other grouping. The 4 stays as positive, and this would stay as 2d minus 1. But now we have our parentheses the same, and we have our grouping outside the parentheses. So we put that in parentheses, and then we put our grouping in the parentheses, and that's our final answer. Here again we have 4 terms, so, but we can combine like terms first, because if you do have like terms, you want to combine them. So you have negative 15p minus 2p squared plus 27. Actually, we're going to keep this as 4 terms because this would be easier to group at this point. We will be able to factor it eventually, how I just wrote it, but we're going to keep it as 4 terms for this particular lesson. So we have 3p minus 2p squared in parentheses and negative 18p plus 27. We're going to take a p out, so we have 3 minus 2p, and then we're going to take a 6 out, it looks like, and we have a negative, or 9 out. We could take a 9 out, and we have negative 2p plus 3, and these are actually the same, they're just written differently. So you have p plus 9 in one set, and you have negative 2p plus 3 in your other set, and this would be your final answer. The next part, they've already factored this for us, so when you have it equal to 0, you need to solve, and you're going to put each part equal to 0, and you're going to get 2 answers. So 3n is equal to 0, and n plus 2 would be equal to 0. So we would solve for n to get one answer to be n equals 0, solve for n and to get another answer to be n equals negative 2. So that would be both of our answers there. This one's not factored yet, so we're going to factor first and then solve. So we can take an 8b out. We're left with b minus 5. And just like the last one, we're going to take each part. What's outside the parentheses, put it equal to 0. What's inside the parentheses, put equal to 0. And we get b equals 0 as one answer, and b equals 5 as the other answer. This one, we need to put it equal to 0 if we're solving. So we need to move the 10x over to be with the x squared. And now we have it equal to 0. Then we need to factor it. So we take an x out. We have x plus 10 left over. And we're going to take each and put it equal to 0. So x would be 0 as one answer, and x would be negative 10 as the other answer. And the last problem is talking about the hop of a kangaroo, and they give us an equation. H equals 24t minus 16t squared. H is the height of the hop. T is the time. So we're supposed to solve for t, but they're making h 0. So we have 0 equals 24t minus 16t squared. We can factor this before we solve. We can have a 4 taken out of each one. So we have 6 left over minus 4t squared. Oops. We can take a 4t out. So 6 minus 4t left over. And we're going to put each equal to 0. So 4t would be 0, and negative 4t plus 6 would be equal to 0. So we have one answer of 0, and we have one answer of positive 1.5. So when they're on the ground, obviously they're going to have a time of 0, but when they hop, each hop is going to be 1.5 seconds. And that concludes Lesson 8.5.